Hi everyone, it's important to note that number 1 is for honors only. So if you are not in Honors Algebra 1, please skip to question 2. So our first step to solve for this problem is that we want to get everything to have the same denominator, which means we need a least common multiple. So 3 is not a fraction, but it's really over 1. So if I need to get a least common multiple between 2, 5, and 1, that number would be 10. So I have to multiply each fraction in order to get 10 in the denominator. So to get 10 when the denominator is 2, I would multiply by 5 in the denominator and the numerator. So remember, whatever you do to the bottom, you have to do to the top. Then my next fraction, remember that x minus 3 is a group over 5. And to get 10 in the denominator, I would have to multiply 5 by 2. And my last is 3 over 1, which I would have to multiply by 10. Now the nice thing about this problem is that once the denominators are the same, which you know you just did, you can cross them off. So I know that this would become 10, so I'm going to cross it off. 5 times 2 is 10, and then 1 times 10 is 10. So I can leave it as my numerator for the first fraction, which is 5x, plus my numerator for the second fraction. Remember, you have to distribute that 2, so it would be 2x minus 6 equals 30. Then I can combine like terms. I can add 5x plus 2x. That gives me 7x minus 6 equals 30. I want to isolate the x. So my first step is to add 6 to both sides. That'll cancel out on the left, and we're left with 7x equals 36. You still want to isolate the x, but the x is being multiplied by a 7, and the opposite of multiplying is dividing. So you divide both sides by 7, and you would get x equals 36 over 7. And that's your final answer. Remember that you do have to check it, but I'm not going to show the checks in this video. But you would take that number, let me highlight it, take 36 over 7, and you would plug it back into your original equation everywhere that you see x, and make sure that the whole left side equals the whole right side. So basically the whole left side, when you plug it into the calculator with x as 36 over 7, should equal 3. Number 2, we have to distribute the term that is in front of the parentheses. So we're going to distribute 7 over 3. So 7 over 3 times 2 is 14 over 3, and then there's an x, minus, and then 7 over 3 times negative 6 ends up just being 14, negative 14, and then minus 1, you bring that down, equals 2 over 3x. Now our next step before we start moving things around is to see if I can combine anything that's already on the same side, which I can. I can combine my negative 14 minus 1. So I would bring down my 14 over 3x. Negative 14 minus 1 is negative 15 equals 2 over 3x. And then I want to get the x's to one side. Since there's only an x on this side, and there's an x and a constant on the left, I'm going to bring this over to the right by doing the opposite sign. So I'm going to be subtracting a 14 over 3x since it's positive. Now you just have to be careful with plugging it into your calculator. These would cancel out. Negative 15 is equal to, and when I subtract it, I get negative 12 over 3x. Now there's 2 different ways that you could do this. Actually 3 different ways. We are going to multiply by the reciprocal because that's the quickest way to cancel out that negative 12 over 3 that's being multiplied to x. So we're going to multiply both sides by the reciprocal. The reciprocal of negative 12 over 3 is negative 3 over 12. They will cancel. And remember, an equation has to be balanced. So whatever you're doing to one side, think about it like a seesaw. You have to do to the other side to balance it out. So when you multiply negative 15 times negative 3 over 12, you end up getting that x is equal to 3.75. Depending on how you did it, you might have gotten a fraction, but 3.75 would be your final answer. You also might have gotten 15 over 4, which is also correct. Okay, moving on to number 3. So number 3, we see two sets of parentheses, x plus 1 and 6x minus 7. The number or term that is in front of that set of parentheses has to get distributed. So I'm going to distribute the 3, and I'm going to distribute, this is a negative 1 that's in front of this parenthesis. So I'm going to distribute the negative 1. That would turn the left into 3x plus 3 minus 5x equals 12 minus 6x plus 7. Okay, and again, before I start moving things around, I want to see if there's anything that's already on the same side that I can combine. So I see a 3x here and a minus 5x. Perfect. And then on the right, I see a 12 and a plus 7. So 3x minus 5x is negative 2x. I'm going to bring down my plus 3 equals, and then 12 plus 7 is 19 minus 6x. Okay, we're almost done. So I want to bring my x's to one side. I'm going to bring over my 6x. It's a negative, so I'm adding it. And that'll keep my x's positive because negative 2 plus 6 is 4x plus 3 equals 19. And then I would minus 3 on both sides. You get 4x equals 16. And then when you divide by 4, you get that x is equal to 4. And that is your final answer. Remember that you do have to check it. So when you plug that back in, you would take the x value, which is 4, plug it into all of the x's that you see, and make sure that the whole left side is equal to the right side. Okay, so for number 4, it's a multi-step equation with decimals. So I would look at both of my sides and see if I can combine anything, which I cannot. So I'm going to bring my x over to the left. Since it's a positive 0.15x, I'm going to subtract it. That cancels it out here. 0.4 minus 0.15 is 0.25x. Bring down our minus 1.2 equals, and then 0.8. Okay, then I want to isolate my term that has x, so I'm going to add 1.2 to both sides. That gives me 0.25x is equal to 2. And then I would divide both sides by 0.25 because I want to isolate the x and solve for x. So once those cancel, I end up with x is equal to 8, and that is my final answer. And again, we're not showing the checks in this video just to save some time, but you do have to do that on your exam. So you would take 8 and replace it where you see x. So you would plug it into x on the left, plug it into x on the right, and make sure you get the same number on both sides. So for this problem, you'll notice that it has infinite solutions. That is going to be our final answer. So let's go through and solve. On the left, there's nothing that I can put together or combine. There's no like term, so I would leave it as 10 plus x. On the right, I have a 1 over 5 in front of my parentheses, so I'm going to distribute. That will give me x plus 10. So now I have x plus 10 equals x plus 10. Let's get the variables over to one side. I'm going to minus 10 from both sides, and that leaves me with x equals x. When you get this as an answer, it means that there are an infinite number of solutions. I can plug in any number for x and it would work out. So that would be your answer, is that there are infinite solutions. For number 6, this is the opposite situation where there is no solution. So let's go through and solve it. So on the left side, I can combine 3 plus 4 to make 7. So that leaves me with 7 plus 3 over 2x equals 4x minus 5 over 2x. I want to bring the x's to one side, the whole numbers to the other, but you can still combine these two terms on the left because they both have, the right because they both have x. So that leaves you with 7 plus 3 over 2x equals 3 over 2x. Now when I get x by itself, which would be subtracting the 3 over 2x and subtracting the 3 over 2x, these cancel, and I'm actually just left with 7 equals 0. So then you would ask yourself, is that true? Does 7 equal 0? It does not. So this is where your answer would be that you have no solutions to this problem.